Hello children, hope all of us are doing good. The topic that we will study today is motion and time, and we will learn about measurement of time, motion, speed, distance time graph for uniform motion. Now in our day-to-day life, we see so many things that are moving and others that are at rest. For example, we see vehicles that are in motion, that are driving. We see birds that are flying, fish that are swimming. At times, we also see or understand motion which perhaps we cannot directly see. We only understand that kind of motion. For example, the movement of air. How do we know about the movement of air? When we see the leaves and trees or branches in the trees moving. So what exactly is motion? Motion is what we understand as the change in position of an object with the passage of time. So in this chapter, we shall first learn about the concept of time, and later we shall learn about the speed of moving objects along a straight line. So let's begin with measurement of time. Now the commonly used units for time are mentioned as hours, seconds, day, year, decade. But how do we perceive them? Now 60 seconds is equal to 1 minute, 60 minutes is equal to 1 hour, 24 hours means 1 day, then 365 days means 1 year. 10 years make 1 decade and 10 decades make 1 century. So 10 decades means 100 years. Then 10 centuries make 1,000 years, which means 1 millennium. Now we know that the earth rotates on its axis and also revolves around the sun. The earth takes almost 24 hours to rotate on its axis, and it takes 365 days to revolve around the sun. Now how do these rotations and revolutions affect us or time? Now as it rotates, so sometimes when we see the sun rising and in the evening we see the position of the sun as setting. Now this change in the position of the sun happens because of the rotation of the earth around its axis. Similarly, when we look at the change in the seasons over a year, that happens because of the revolution of the earth around the sun. Now, in earlier times, how was time calculated? Like for example, a sand clock was used by the Romans. Now, this worked on the principle that the sand from the upper chamber falls into the lower chamber in a fixed amount of time. And this fixed amount of time was the unit in which time was measured by them. Then another method was sundial, as you can see in this image over here. So the sundial was used as it worked on the principle that as the position of the sun in the sky changed, so did the position and length of the shadow cast by an object. And a few hundred years ago, Maharaja Jai Singh II of Jaipur made huge sundials to measure time. These can be seen even now at Jantar Mantar at Delhi, Jaipur, Varanasi, Ujjain and Mathura. The largest sundial in Jaipur can measure time up to an accuracy of 2 seconds, but cannot be used after sunset. Now this brings us to the simple pendulum. Now as you can look at this image here, the simple pendulum works on the principle that if there is a string and some heavy weight or perhaps a weight which is perhaps a small metallic ball is attached at one end, and this string is attached to a support that remains constant. Now when this string is pushed a little, it moves to and fro. Now the frequency of time or the amount of time taken by this string to make one to and fro movement will remain the same as long as the length of the string remains the same. Now, this metallic bob here is called the bob of the pendulum, and this to and fro movement is called its oscillation. So, the time taken by a pendulum for one oscillation is known as its time period, and this time period will remain the same as long as the length of the string remains the same. So, a pendulum of about 25 centimeter length takes exactly 1 second for one to and fro movement about its position of rest, and this position here is its position of rest. So, let's do an important or interesting activity here. The aim is to measure the time period of a simple pendulum. We need to suspend a metallic ball or bob by a long thread from a rigid support. Your simple pendulum is ready. Now set the simple pendulum in motion. Note the time in your watch when the bob is at an extreme position, say A. And when the bob again comes to the position A, count 1. Now, each time the bob reaches this position A, increase the count by 1. Check the time after 25 such oscillations. Find the time taken in 25 oscillations. Now, the time taken for 25 oscillations is equal to small t. Time taken for one oscillation is equal to capital T, which is equal to small t divided by 25. Now, a mechanical wristwatch has a balance wheel instead of a pendulum, which serves the same purpose. Nowadays, electronic wristwatches are available in the market. These work on a different principle. These watches have the crystals of a substance called quartz. अब क्वार्ट्स के जो क्रिस्टल्स हैं ये बहुत तेज प्रिसाइज रेट पे वाइब्रेट करते हैं, और इन वाइब्रेशंस को मेजर करके हम टाइम एक्यूरेटली पता कर सकते हैं. जो क्वार्ट्स की क्लॉक है ये पेंडुलम क्लॉक से ज़्यादा प्रिसाइज टाइम बताती है. अ स्टॉप वॉच इज़ यूज्ड फॉर मेजरिंग शॉर्ट इंटरवल्स ऑफ टाइम एक्यूरेटली. Nowadays, several digital watches available in the market can also be used as stopwatches. Many of these digital watches do not have hour, minute or second hands. They display time in digits. A fact strip here. Atomic clocks are also called caesium clocks. Their working is based on the radiation released by each of the atoms present in the material. Now this brings us to मोशन. मोशन क्या है? कोई भी ऑब्जेक्ट किसी टाइम के लैप्स होने पर या टाइम के बीतने पर जब अपनी पोजीशन को चेंज करता है, इसको मोशन कहते हैं. लेट्स लुक एट स्पीड. नाउ द डिस्टेंस कवर्ड बाय अ बॉडी इन यूनिट टाइम इज कॉल्ड स्पीड. अगर हम कहें कि कोई ऑब्जेक्ट 50 किलोमीटर्स पर आवर की स्पीड पर मूव कर रहा है, तो इसका मतलब है कि 1 घंटे में वो ऑब्जेक्ट 50 किलोमीटर्स ट्रैवल करता है. नाउ दिस ब्रिंग्स अस टू यूनिट्स ऑफ स्पीड. नाउ यूजुअली स्पीड इज डिनोटेड बाय किलोमीटर पर आवर, बट द एसआई यूनिट ऑफ स्पीड इज मीटर पर सेकेंड. लेकिन हम किलोमीटर पर आवर को मीटर पर सेकेंड में चेंज कर सकते हैं एंड वाइस वर्सा, यानी कि मीटर पर सेकेंड को किलोमीटर पर आवर में चेंज कर सकते हैं. कैसे? 1 किलोमीटर पर आवर इज इक्वल टू 1000 अपॉन 3600 मीटर्स पर सेकेंड. और सिंप्लीफाइड वे में क्या हो जाएगा? 1 किलोमीटर पर आवर इज इक्वल टू 5 डिवाइडेड बाय 18 मीटर पर सेकेंड. तो अगर हमें किलोमीटर पर आवर को मीटर पर सेकेंड में कन्वर्ट करना है तो हम उस वैल्यू को 5/18 से मल्टीप्लाई कर देंगे. और अगर हमें मीटर पर सेकेंड को किलोमीटर पर आवर में कन्वर्ट करना है तो हम मल्टीप्लाई करेंगे 18/5 से. अ फैक्ट स्ट्रिप हियर. अ फाइटर जेट एयरक्राफ्ट कैन ट्रैवल एट अ स्पीड ऑफ अबाउट 2400 kilometer per hour, which means 6666 meters per second, which is almost 2.35 times the speed of sound. every vehicle has a speedometer console which consists of a speedometer and an odometer. जो स्पीडोमीटर है वो गाड़ी की इंस्टेंटेनियस स्पीड बताता है और जो ओडोमीटर है वो डिस्टेंस कितना ट्रैवल किया है उसको डिस्प्ले करता है. नाउ लेट अस लुक एट यूनिफॉर्म मोशन एंड नॉन यूनिफॉर्म मोशन. अगर आप कंसिडर करें कि कोई कार एक स्ट्रेट लाइन पर जा रही है और लेटर से पहले सेकंड में वो 20 मीटर्स ट्रेवल करती है, सेकंड में भी वो 20 मीटर्स ट्रैवल करती है, फिर थर्ड सेकंड में भी वो 20 मीटर्स ट्रैवल करती है एंड सो ऑन. तो इसमें क्या है कि हर सेकंड में ये कार 20 मीटर्स ट्रैवल करती है. सो एज द कार कवर्स equal distance in equal intervals of time, it is said to have a uniform speed and is said to be in uniform motion. So as the car travels equal distances in equal intervals of time, it is said to have a uniform speed and is said to be in uniform motion. The time interval in this case may be small or big. On the other hand, if a body covers unequal distances in equal intervals of time, the body is said to be in non-uniform motion. Now let us look at average speed. किसी भी ऑब्जेक्ट की एवरेज स्पीड को डिटरमिन करने के लिए जो टोटल डिस्टेंस उस ऑब्जेक्ट ने ट्रैवल करा है उसको हम उस डिस्टेंस के लिए जितना टाइम लगा है उससे डिवाइड करते हैं. सो द एवरेज स्पीड इज इक्वल टू टोटल डिस्टेंस डिवाइडेड बाय टोटल टाइम. द टोटल डिस्टेंस ट्रैवल्ड बाय द बस इज 20 किलोमीटर्स, 40 किलोमीटर्स, 5 kilometers, and the total time of the journey is 5 hours. So the average speed becomes 20 plus 40 plus 5 kilometers divided by 5 hours. This is equal to 65 kilometers by 5 hours, and this is equal to 13 kilometers per hour. This brings us to another activity. Complete this table given here. So you have the distance traveled, time taken, and average speed columns given here. So if you have any two values, you can calculate the third value by using the same formula, that average speed is equal to total distance traveled by total time. Now this brings us to distance time graph for uniform motion. Now suppose a car is moving on a straight road which has no traffic. It starts from a lamp post at 9 a.m. The odometer reading after every 5 minutes is noted. Now you can see that the car travels every 5 kilometers in every 5 minutes for the entire journey. That is, it is traveling in a straight line. It covers equal distances in equal intervals of time. If you calculate its speed for the entire journey or for any interval of time during the journey, it will be the same. So speed for the entire journey, so it covers 20 kilometers in 20 minutes or in 1/3 hour. So speed is equal to distance upon time, which is equal to 20 kilometers divided by 1/3 hour, which is equal to 60 kilometer per hour. So speed for the time interval 9 a.m. to 9:05 a.m. It covers 5 kilometers in 5 minutes or in 1/12 of an hour. So speed is equal to distance upon time, that is equal to 5 kilometers divided by 1/12 of an hour, that is equal to 60 kilometers per hour. तो आपका डिस्टेंस कितना भी लगा हो, टाइम जितना भी लगा हो, अगर आपका डिस्टेंस इक्वल इंटरवल्स में सेम ट्रैवल हो रहा है तो आपकी स्पीड सेम रहेगी, which is 60 kilometers per hour. Now let us look at this table that shows distance time data of a car traveling on a road with no traffic and showing uniform motion of time. So you have time, odometer reading, distance in kilometers from the lamp post, and distance in kilometer traveled in 5-minute intervals. So you can read this data. So you can calculate the speed for any of the given time intervals. It will be the same. We say that the car is in uniform motion. A body is said to be in uniform motion if it travels in a straight line and covers equal distances in equal intervals of time. In other words, the direction of motion and the speed of the body in uniform motion do not change. Now let us look at this data here. It shows distance time data of a car traveling on a road with traffic. So this shows non-uniform motion. Now at 9 a.m. the odometer reading showed 5630. So distance in kilometer from the lamp post is 0. And distance in kilometers travelled in 5-minute interval is none here. At 9:05 a.m. the odometer reading is 5632. Distance from the lamp post is 2 and distance in kilometers travelled in 5-minute interval is 2. At 9:10 a.m. again, if you look at the odometer reading, the distance from lamp post is 5, but the distance travelled in 5-minute interval remains 2, and so on and so forth. Now, if we have to show these two datas in a time graph, distance time graph, so we can choose a suitable scale to represent the two quantities on the two axes. So 1 centimeter will show 5 minutes on the time axis and 1 centimeter will show 5 kilometers on the distance axis. Now plot the points corresponding to each set of values for distance and time. Now for example, when time is 0 minutes, distance is 0 kilometer. Hence this point is the origin itself. When time is 5 minutes, distance is 5 kilometers. The point lies on the intersection of the vertical line at 5 minutes on the x-axis and the horizontal line at 5 kilometer on the y-axis. That is point A. Similarly, plot the other points. Join all the points on the graph. Did you get a straight line? The graph of distance versus time for uniform motion is always a straight line. Now suppose the same car is traveling on another straight road with traffic on it. It continues to travel in a straight line but has to slow down or speed up from time to time because of the traffic. So in this case, if you have all your readings about the distance covered and the time interval that has lapsed, the graph that you will make will not be a straight line. It will be like this. Now in non-uniform motion, what happens is that the car, even though it is traveling on a straight road, still it is not traveling at the same speed. For example, it may travel for some kilometers in a 5-minute interval, but in the next 5-minute interval, the distance travels is not the same. So in such a case, when you make a graph, the graph will not show a straight line. It will be like this. So a body is said to be in non-uniform motion if the speed or direction of the body does not remain constant. Let's revise. Measurement is the comparison of an unknown quantity with some fixed quantity of the same kind. Physical quantities are quantities such as length, weight or mass, time, temperature, speed, etc. that can be measured. A standard unit is one that is uniformly used by everyone. Measurement of time requires something that occurs or appears at regular intervals. For example, rotation of the earth on its axis and to and fro motion of a pendulum. The time period of a pendulum with a constant length is fixed. Speed is the distance travelled by a body in unit time. A body is said to be in uniform motion if it travels in a straight line and covers equal distances in equal intervals of time. A body is said to be in non-uniform motion if the speed of the body does not remain constant. The graph of distance versus time for uniform motion is a straight line. So I hope that the chapter is clear to all, and answering questions based on this chapter will now be easy.